Hi, my name is Jorge Aarao, and welcome to Methods of Applied Mathematics 1. And what are we going to study in this course? Well, I thought that instead of just telling you, I would make a little demonstration. I have here with me a toy I bought many years ago. It's very popular with my son, and it has two parts. This is a movable part, and that's a fixed part, and there are some magnets in it. So I'm going to place the toy here, and you can probably see that it is floating on air because a magnet keeps it up. And I'm going to do what you're supposed to do. I'm going to spin it. Oops, I spun it too fast. Yeah, there you go. And that's all this toy does. It just spins like that very calmly and quietly. And it has the speed of rotation, a frequency, if you will. And it's very stable, as you can see. Now, something very interesting happens because as you go along, it loses some of its speed due to friction. So you could say it loses energy. And it starts to spin slower and slower until all of a sudden it's not stable anymore. It starts to vibrate violently, well, as violently as that will go, and then it slows down again and is stable once more. And that is a feature of many mechanical systems. It is a feature of life, if you will. You have some systems, and they could be a toy like this, and they could be your automobile, and they could be the wing of an airplane. Some systems that behave very well under some conditions, under some frequencies, and not so well under other frequencies. And it's very important to understand how it happens. You don't want to be in a car that is working well at a certain speed, and then all of a sudden when you hit a certain other speed, the car starts to shake, without control. You don't want that. You don't want an airplane to behave like that. The toy is okay. It can behave like that as much as it wants. Well, we are going to study the mathematics that will allow you to understand this sort of phenomenon. This sort of phenomenon is more broadly called an oscillatory phenomenon, anything that has to do with oscillations. What is the mathematics that will allow you to study oscillations? Well, it is sines and cosines, because if you remember, sines and cosines, they oscillate. That is the right language to use. Now, it's not only that. Here is another application. I have a rubber band here, and the rubber band is because I forgot to bring my ukulele here. And if you strike the rubber band, it vibrates and it emits a sound. Anything that is has a vibration like that on a string will emit a sound, and we want to understand the nature of sound and how it behaves as well. Here, I have my voice coming out of a larynx and trachea and vibrating the vocal cords or the vocal folds in here and emitting sound. How is the sound? The frequency is about 200 hertz, I think, or thereabouts, and it's traveling through the air, and it's hitting the microphone, and it's being transformed into electrical vibrations, and that is transmitted to the camera and to the electrical device we have, and then it's encoded, it goes to the web, and you're listening to it. We want to understand perhaps not the whole of that process, but the basics of that process, the mathematics of that process. And that's not all. Here, I have a prism. Okay? And the prism takes white light, and the white light goes in, and it gets decomposed into the spectrum of lights, just, in fact, as a rainbow does. And if you've seen a rainbow, you know that happens all the time in nature. Well, how is it that white light is composed of different colors? And what does it mean to be a different color? It has something to do with frequency. That's the understanding we have. Different colors have different frequencies, or rather different frequencies have different colors. And we can see it. Well, what is the mathematics that will allow you to study that as well? So it is not only the behavior of mechanical systems, or the behavior of sound, or the behavior of light. It is anything to do with oscillations, how they happen, how we can break a complex white light, a complex signal, into simpler different lights, signals. We are going to study this in this course. We are going to try to give you the mathematical tools to understand this, and we'll see what we can take from it. Thank you very much. I hope you'll enjoy it.